Welcome to my most complex inferencing pipeline ever. What? Listen, I needed to deploy my machine learning model over a GPU machine, but since my users might send real-time requests, multiple requests at the same time, so I launched multiple GPU machines in case if one of them is busy with doing a request, the other ones will handle the other requests coming in for doing the prediction. I'll definitely increase the number of GPUs in future and absolutely pay them with your bank account. Oh, by the way, I added more great thing. I created a customized inferencing server so I can receive multiple real-time requests, make them as a dynamic batch request, and then send it to my model for prediction. Now I will have high throughput and also low latency as well in my predictions. Genius. Mr. Genius, can I add one more quick point on that as well?
Sure.
Well, first of all, you could use an open source inferencing server called Triton that you could gain all these benefits out of it and save your time instead of developing this, and of course saving costs instead of launching all those crazy number of GPU machines. You mean I could have concurrent model execution and even dynamic batching with a Triton inferencing server? Yes, right? And much more benefits. Yeah. Can I use it in Azure ML? Yes, I can show you as well. Okay. Let's go. Hello everyone, this is MG, hoping as always you're doing great. In this video we're gonna talk about an open source inferencing server called Triton, which can significantly help you to optimize your inferencing for both batch or real time. For instance, you could have concurrent model execution and having several instances of the same model getting executed over the same compute that you have deployed your model, so you can handle parallel requests and do the prediction for them. Or you could create a dynamic batch out of your requests and have even sequential batching as well, and much more other benefits. By the way, it can support multiple different deep learning and machine learning frameworks, and it is now also integrated with Azure ML as well. So enough talking and let's check it out. Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. Alright, the first thing that we need to start with is what is the value proposition that we are sort of approaching here, or what is the initial challenge that we are trying to mitigate through what we're introducing as Triton and how it is integrated with Azure ML, okay? So, as we all know nowadays, AI applications are everywhere, right? From different scenarios like NLP, computer vision, different all type of AI applications and AI deployment. And when we talk about model deployment or inferencing, this is the process of querying an AI model to do a prediction, right? So let's say you have deployed a model that does some sort of regression prediction. So you have your input data, input features, and you have to query the model with your inputs, and the model will retrieve you back the predicted value. So this is the inferencing phase that we're gonna mainly focus on today. And for modern applications, I would say majority of AI applications, that inferencing process should be pretty fast and I would say close to immediate, right? That's why in order to assess the performance of the model in inferencing stage, there are mainly two quantified metrics that people are talking about it. One of them is latency that I'm gonna highlight, and the other one mainly is throughput. There are more, but latency and throughput are a couple of main point metrics to assess the inferencing process of a model execution. So let's start with the first one. What is latency? Well, latency is defined as the response time for a single query. So just for a single call that you call a model with the inputs to do the prediction and retrieve the predictions back, how long that process gonna take? Are we talking about milliseconds, seconds, whatever it is? This is latency. And of course, we would love to reduce the latency to make sure we can have a pretty quick response, get it back as soon as we call the model. The second metric for inferencing is throughput. And what is throughput? Throughput is defined as the number of queries processed by time unit. Let's say in 1 minute, how many responses my model can handle. Maybe 1 minute the model is able to do just one prediction, to handle just one query, or no, 100 of queries. And of course, we would like to increase the number of throughput, right? The higher number of queries we can handle by the unit of time, 1 minute here was an example, is better, right? And at the same time, we want to reduce the latency, because if the response time for my model query, a single query, is lower, that means my process is faster. So we're achieving these two. Well, welcome to all different configurations that you need to do, right? If you want to deploy your model on GPU, on CPU, you have to check your OS operating system, check out the capabilities of the compute that you're deploying a model, come up with some custom server, custom model to make the predictions pretty fast, or make a sort of a dynamic batch out of the request to have a high throughput. So it is not really easy to tackle that, especially when you work with different backends. Your model may be generated by different frameworks like TensorFlow, PyTorch, ONNX. This is a great actually optimized format for deploying models. I already created a separate model out of it. I want to add the video link on the top right of the screen here. Check that out. ONNX is an optimized format for deploying your models on different type of hardwares like edge compute. This is a very, very powerful resource, so make sure you check that out. Now the question is there any way that I can have a server that does this sort of optimization for me when I deploy my model? So something to have low latency, high throughput, that can support multiple backends, and I can just deploy it through that server and call it out. The answer is yes, and this is exactly the purpose of this video, which is called Triton open source server for inferencing that can support both real-time and batch stream. What are the benefits? I just explained you the benefits: low latency, high throughput, supporting different backends, and what I'm gonna explain also further, that how Triton is improving your latency and throughput with this inferencing server. When you deploy your model through Triton inferencing server, both HTTP and gRPC protocols are supported for calling your model. Your client can use Python or C++ to call your model from the client perspective. And you will see on the back end, there are some optimizations that Triton inferencing will do to achieve these two benefits that I just described. And these two are just some of the benefits. And then run it over CPU or GPU to do the prediction. Let's see how Triton is helping us with latency and throughput, and how it is actually making that efficiency for us. There you go. This is the GitHub link, the official GitHub link for open source Triton inferencing server. If you just simply search Triton inferencing server GitHub, you will see the link coming in, and here are the list of some of the major benefits that you can gain out of this open source server. I already talked about low latency, high throughput that can be achieved by dynamic batching and concurrent model execution. This is one of the main two features that Triton is offering, plus some others that I already explained, like it is supporting multiple deep learning and machine learning frameworks. You can have some sort of sequence batching, different type of backend API. The HTTP and gRPC, both protocols are supported for inferencing to call the model, and lots of more. You can check that out. But let's focus on the main two that can support with low latency and high throughput, which is concurrent model execution and dynamic batching. So let's start with the first one. What is concurrent model execution? So look at this one. When we talk about concurrent model execution, let's say you have deployed a model over GPU as an example, and suddenly two requests or two people send at the same time simultaneously send requests to your model endpoint to do a prediction, right? So now in an usual scenario, you might think that, okay, the first request, one of the requests gonna get executed first, the other one will be queued until the first one is done, and the second one will start to get executed. But with Triton, what Triton will support you is, it will help you to sort of start immediately one of the request, it doesn't wait to have the request done. It will actually generate a duplication or sort of create multiple instances of the same model. Here's, for example, I have the instance 0 and instance 1. And both requests in parallel at the same time can be executed concurrently. So here I have model, but I have two instances of my model, and in parallel they're handling requests that I receive at the same time. Of course, now I have parallel execution. I am receiving more and more requests with high throughput and with low latency. There's no need to wait. So now I can have concurrent model execution with generating multiple instances of my model over the GPU that I have on the backend side, right? And this is not just for GPU. The GPU scheduler will handle that as well with Triton, but also for CPU, that's going to be pretty similar scenario for concurrent model execution. The only difference is that the CPU thread execution for each model is handled by systems operating system or OS, but for GPU there's a GPU sort of a scheduler that will support you for having concurrent model execution. You will also have the chance to sort of manually customize and configure some of these settings. For example, here when we talk about concurrent model execution, right? You can specify and tell Triton that how many instances of the same model you want to get duplicated, so you can handle parallel execution, right? For example, you have model 1, model 0, and for model 1 you're saying that, hey, maximum 3 concurrent execution I gonna have for my model 1. So what's gonna happen if I receive all requests at the same time simultaneously? Maximum 3 of the model 1 is now, you can see it's launched, handling my request. Now the fourth one, when arrive at the same time, the fourth one should wait to let that first 3 instances of the model 1 get executed and done, respond the request, and then the fourth one gonna get executed. So you have the flexibility to customize these numbers here. Now the other benefits I wanted to highlight a little bit further, which is pretty cool, is dynamic batching. So let's talk about what is dynamic batching and how it can be a benefit for us. Let's say now you have deployed a real-time endpoint, a real-time model that is listening to sort of do the prediction based on the request that it is receiving. Now what you are specifying with dynamic batching is, hey, instead of sending requests to one individual request to my model real-time endpoint, do the prediction, and then do the second one, third one, so on and so forth, let's pause for a second. I'm gonna specify a maximum timeout as an example that, hey, wait until you receive, for example, 10 requests out of for the real-time endpoint to do the prediction. So 10 requests for my predictions coming in. So I make a batch requests out of those 10 individual requests that I just received, and then ship them to the model in an efficient way to do the execution. So I'm sort of increasing the throughput, the number of units of requests that I can handle with the given unit of time, based on creating a batch unit out of the individual requests that I receive. So I can specify, let's say, the maximum delay that you can tolerate, for how long you're gonna wait for individual requests to create a batch out of it, right? That's a sort of configuration. But you will have the flexibility as well to make a batch out of your request and then ship it for inferencing and model execution. Awesome. Now let's check it out how in Azure ML and how it is integrated in Azure ML to sort of utilize this great benefit. And do you need to manually install and configure Triton inferencing server in Azure ML, or no, there's a simpler way to do it. So let me launch my Azure ML. There you go. And as you all know, in Azure ML, you can create a compute which I have already created, and you can access to the terminal, the Ubuntu machine of this compute. So you can just simply launch the terminal. And what I'm gonna do, I want to clone the Azure ML example that has the artifacts that we can see how we can deploy a model through Triton server, right? I have already ran the sort of the command lines that I want to here showcase you. Honestly, it's pretty similar. With just 4 or 5 lines, we're gonna do it together. So what I did first, you have to clone Azure ML examples, git clone Azure ML examples. This is sort of the URL. I already did this. That's why you will see that under my admin folder, which I have Azure ML examples. Well, The example that we're gonna run is here. If you go to CLI, endpoints, online, you'll see that there's something called Triton. And if I open it for a single model, you'll see that I have models, model number one, version number one. There's a model, I think that's a DesNet model. It is with ONX format. Again, it's the best practice to actually have ONX with Triton, because ONX is an optimized model format for inferencing, and now you're also using Triton as an optimized inferencing service, so you have the combination of best of the bests. You might question why this is the sort of the structure that I have, which is models one, and the number of the version, and then the model artifact. The reason is this is a must to have. This is sort of the model architecture of the folders that you have to specify your model for deploying over Triton. You can see that in the GitHub link of Triton that I was just showcasing you at the beginning of the video. You can see on the model configuration part, it says that these are different model types that we support: TensorRT, ONNX, the one that we're using, TorchScript. But the one that we're using, it says that this is sort of the way that you have to specify your repository. So you have the path, the model name, sort of the config, and then the number of the version plus model ONNX. That's why you'll see this is sort of specified here. Okay, so now what is next? You have to sort of navigate to this path to be able to deploy this model. How? You can use CLI command line, which I used, or you can use even UI, Python SDK. You know that there are different ways to deploy an online managed endpoint in Azure ML. If you don't know what is managed online endpoint in Azure ML, there's another video I created. I'm gonna add that to the top right of the screen. Check that out. I assume that you know already what is managed endpoint, real-time endpoint for Azure ML. This is what we're gonna actually deploy using Triton Inferencing Server to deploy this ONNX model. So what is next? I have to, so make sure you have also done AZ login, so you have authenticated. This is the first thing you need to do. And then I assume that you have cloned, and what you will see is similar to what I'm showcasing here. And after that, what I executed was just simply navigate to Azure ML examples folder, which I have it here, and then go through CLI folder that I just show you the reason why I have the examples there, and specify base path here. So the base path here, it's simpler to actually put the path in a variable because we want to use that path for deployment. So I'm gonna actually add the link of the codes and examples that I'm executing here in the video description. So all good with that. So the base path for me here is, again, what I showed you: endpoints, online, Triton, under single model that we just opened. This is what we will see, and this is exactly where we are. Okay, let's define that base path. And then you have to create an endpoint first, and then deploy your model over endpoint. So two steps are left. First, creating endpoint. Second, deploying a model over that endpoint. How we can achieve these two steps? Well, as Azure CLI as one way to do it, this is the command line that you need to run. AZ ML online endpoint, create, give it a name. Mine was actually Triton. I already actually done this, so I'm not going to redeploy this again, but just show you how I did. So I went back here, I changed this to Triton. Again, you can put any name. Triton is just an example. You can put, let's say, test. And you can see that it is looking for a YAML file that is under my base path to deploy this. What is that YAML file? Good question. Let's check it out. It's called create manage endpoint, which is this one. Just pretty simple. It's defining the schema version, saying that, hey, I have an endpoint that I'm gonna deploy with the given name and authentication way. The way that I'm gonna authenticate to call this model when it's deployed is through Azure ML token. That's it. As soon as I executed that, I went to my endpoints.
not executing this command line with using the YAML file. I came to my endpoints and I figured out, there you go, in the real time I have a new endpoint called Triton, but nothing is now deployed over it yet. It's just an endpoint definition. Now what is the next command line, or the last one actually, to deploy my model over this endpoint is, let me just remove this one. Again, I want to use Azure CLI to deploy my model, which is, let me copy and paste the code here, copy, and there you go. Now I'm saying that I want to deploy my model over an endpoint. What is the endpoint? The endpoint that I created, well, the name was Triton, so you have to use the same name that you gave to your endpoint to make sure Azure ML will understand, okay, what endpoint you are trying to deploy your model. And then how? Well, I have another YAML file that talks about how I'm going to deploy this model, and I want to have all the traffic coming into this deployment because this is the only deployment that I have. So let's check out what is the deployment configuration. There you go. It's saying that, blue-green deployment. Again, in the other video I mentioned, I already explained what blue-green deployment, rollout deployment is. So assume you already know it. I'm just saying that, hey, I have a model with the given name, version, under this path. There you go. I want to deploy this over a compute. Well, for this specific model, I think that's a DesNet model. You need to sort of have GPU. I didn't have quota in my subscription to actually deploy it over a GPU. If you have it, you should be fine. That's why I changed it to a CPU-based machine. I don't think it's gonna work, but just for the purpose of showcasing the deployment and demo, I changed it. But here's the key part. This is sort of the magical stage and integration with Azure ML. For the type, just with saying Triton, it will know that you're deploying a model over a Triton inferencing server. What does that mean? Remember, for deploying a model, you have to sort of have a scoring Python code. You have to tell how you load the model, do the featureization, return the value back. You also have to specify the environment that you need to deploy the model. The pip packages that need to be in place in your deployment environment. So you need to have two things: a scoring file, environment. But because I'm saying this is Triton, then an Azure ML is integrated with Triton, it doesn't need the scoring file and environment anymore. That's it. So I executed this command with this given YAML file path I have here. Done. What happened is I came to my endpoint. This was already there. I launched it. And there you go. I see that there is a blue one deployed for me for the compute that I specified. All the traffic is going there. And the scoring script is auto-generated because it's Triton. And even if the environment is auto-generated, because it is Triton. And the model that I used was the DesNet, as you know. The model also got registered. If I go to the models, let's check this out. You see that there's a sample that got registered. And if I check out the artifacts, you'll see that the way that this model is stored is based on the model repository configuration that Triton is expecting if it's on NX, based on the documentation that I showed you. And that's it. Now in my endpoints, I have a model deployed over inferencing server called Triton with getting benefits, but I didn't manually configure anything because of this nice integration of Azure ML with Triton, with just specifying the model type as a Triton server over Triton server. I was able to deploy it. And that's all.
How big would you dream if you knew you couldn't fail? Wish you great moments, my friends, and we'll meet you shortly in the next video. Take care.